Looking at important aspects of trigonometry function under integration, that is standard integrals for trigonometry. Yes, integral of cos x dx is equivalent to sine x plus c. The integral of sine x dx is equivalent to negative cos x plus c. These are standard integrals. They don't vary. They are constant. That whenever you integrate sec square x dx, it ought to give you tan x plus c and nothing else. Whenever you integrate cosec square x dx, it ought to give you cot x plus c and nothing else. Whenever you integrate sec x tan x dx, it ought to give you sec x plus c and nothing else. Whenever you integrate cosec x cos x dx, it ought to give you negative cosec x plus c. As well, if you decide to integrate cos x in bracket ax plus b dx, it gives you 1 over a sine x in bracket ax plus b plus c after closing your bracket. Also, whenever you integrate sine x ax plus b, close your bracket, dx, it ought to give you negative sine of 1 over a cos in bracket ax plus b plus c. Whenever you integrate as well, the integral of ax sine ax plus b, it gives you the same thing. So that was just a recap. Alright, so since we have gone through this, we'll move to our next slide and try our hands on little things. We're having here sine x dx. Say integrate it. So how do we go about this? Mind you, there's a sign there, and we have a standard, it's a standard integral, and we have x 6x here. To start with, we just say let u be equal to 6x. There are a shortcut for this, but I will give you the shortcut. But before we look at the shortcut, let's look at the long cut a bit, so that you feel a bit relieved when I release the shortcuts to you. Alright, so let's go through this. In case of the long cuts or the long road to Rome is very important because of your theory questions, but shortcuts to Rome or to the solution is also still important because of objective solutions and objective questions. Alright, so sine 6x dx, to integrate it, let u be equivalent to what? 6x. And that gives us that what? If we differentiate u with respect to x, we have 6. That is, removed x raised to power 1 minus 1, and that is x raised to power 0, and that gives us what? 6. So if we cross multiply, we have 6 times du equal to 6 dx, then dx is equal to du over 6. So if we put dx equal to du all over 6 in the equation that is coming next, definitely, which is putting the dx, moving it over to this place and replacing it wherever I see the x, you fix up du all over 6, because we have made the x now the subject of formula. The whole game show here is that what we want to, since we have declared this to be 6x, we also want to eliminate anything that has to do with x in this expression. And to do that, we have to find a substitute that did not have x as a variable to replace the dx, and by doing so is to differentiate this, which we did here. Du all over dx is equivalent to 6. We'll cross multiply, it gives us dx, and du equal to 6 dx. We'll make the x subject of formula by dividing both sides by what? By dx, and that gives us, by dividing both sides rather by 6, we take this 6, we divide here, the 6 goes off, and we have the x, and this is the dx. We use 6 to divide this one, and this is du over this over 6. So anyway, when I see the x, we put du all over 6 in the equation. And the next equation we're talking about is this, when this has been substituted already. So let's look at it. Now we say integral of sine u dx is equivalent to integral of sine u du all over what? 6. We have done the substitution now. So move this one behind the integral. We have 1 over 6 integral of sine u du, which is equivalent to 1 over 6. Open your bracket. The negative sign cos u plus c. Remember, this is a standard integral, and that's why we're having minus cos u if you check up in our previous slide. So recall, since we have gotten this as an answer, but we shouldn't leave it in u because we assume u, we declared u initially. So we have to replace it with the original. Alright, so u is now equal to what? 6x. And if u is equal to 6x, we fix it back into this equation. Then we now have that 1 over 6 integral of sine 6x ds is equivalent to negative 1 over 6. We move the negative here behind, which is cos 6x plus 6. And that is our final answer. And that's just the integral of sine 6 dx, because this is differentiable and this is also differentiable. So both of them are differentiable. Then we have to differentiate one. That is this. That's what we did here. Du over dx, differentiate it. But you use it to divide the expression. And that is why we got 1 over 6. Mind you, we didn't use it to multiply the expression. If I use it to multiply this expression, which is this here, we'll be having 6 integral of sine u. Even though we are doing differentiation, in the midst of integration, the rule still remains that you have to divide with it, not multiply. When you multiply, you have done differentiation completely. But when you differentiate and divide with your results, then you have done integration. So that is exactly what is there. So this is differentiable, this is differentiable, but we differentiated only this one, but integrated only this one. And that's why you see it here, that when we integrated, we went by special integral, we integrated sine u here, and we got negative cos u. If you check in our previous slide, it's a standard integral. So that is how it works. That is how it works. Okay, we'll come again here. We want to look at another question. This has to do with exponential. It's also a kind of special indeed. If you have integral of exponential 4x dx, to integrate it, you declare u to be 4x, then differentiate u with respect to x, and that gives us what? That gives us 4. And if that gives us 4, we'll make the x the subject of formula by simply what? Multiplying both sides. We'll have du equal to 4 dx. Now to make the x subject of formula, we'll have it here, dx is equal to du all over 4. And that is what? The integral for exponential u, now we have removed 4x, is what? Du all over 4, which is equivalent to move the 1 over 4 behind. And that is what we have here, which is equal to integral of u du, integral of exponential u du. We're integrating now with respect to u because we have replaced our dx with du. So move further to integrate. So as we integrate this, it gives us plus c. But recall that u was something we declared earlier. So you return the declaration back to replace the original. So we have integral of x raised to the power 4x dx is equal to 1 all over 4 exponential 4x plus c. And that is our final answer. Take note, exponential is special in its integration. So whenever I integrate an exponential, it's still the exponential itself. If you integrate it as you integrated it, nothing changed. So the only thing that changed is the power, which we differentiated and used it to divide the expression. So it's also a standard integral, but an exponential one. An exponential one. All right. So let's proceed. And the next one is integral of 2x minus 7 raised to the power 3 dx. Now, if you look at this, if you look at this a function that has a function inside. So we still use our normal procedure of declaring u to be 2x minus 7. And if that is the case, we say let u be 2x minus 7, and that gives us that the u dx is equivalent to what? 2. Then, if the u dx is equivalent to 2, we'll cross multiply to make the x the subject of formula, and that will give us what? That will give us the u rather is equivalent to 2 dx. So making the x subject of formula, we'll divide both sides by 2. We'll have the x divided by the s equivalent to what? The u all over 2. Alright, so on substituting replacing our u into this expression, mind you, this is an expression that came from here, so this is now u, so we are fixing it back. We have integral of u dx, which is not compatible. We'll replace it with the compatible one, with du. Once we do that, it is compatible. Now we can integrate, push the half behind and integrate, and on doing that, we have half raised to the power of what? U raised to the power of 4 divided by what? 4 plus c. Plus c. So that is our integration. Mind you, we're not yet through. In our next slide, we'll definitely replace this u with 4. Sorry, we'll replace the u with the original declaration that it had before we declared it. The original expression it was before we declared it. So here is it. We look at half u raised to the power 4 divided by what? 4. That is integration plus c. Recall that our u is what? Our u is equivalent to 2x minus 7. Replacing it, we have what? We have half 2x minus 7 raised to the power of 4 divided by 4 plus c, which is the constant of integration. So thus, we multiply and we have 2x minus 7 raised to the power of 4 in bracket divided by 8 plus c. And that is the final answer for the integration of this kind. Now we have looked at integration of power, because this is an integration of power. It has power. We have looked at integration of trigonometry. We'll also look at integration of exponential. Now let's look at integration of expression with roots. And that is our next question here, which is integral of 5x minus 3 dx. How do we integrate this? We'll simply do what? Alter our expression, but in the correct form, not complete alteration out of sense, but alteration in the right form. Look at it. This is 1 over 2, so it becomes 1 over 2 here, dx. So we'll declare our u, let u equal to 5x minus 3. Then becomes du all over dx is equivalent to what? 5. So therefore have ds is equivalent to du divided by 5. Of course, you should have been familiar with this by now. Dx is equivalent to what? To du divided by 5. So we proceed to the integral of 5x minus 3 raised to the power of what? Half dx is equivalent to what? To the integral of u raised to the power of half du dx now. So let's do our substitution here to replace it with our du. So that is what we now have. So integral of u raised to the power of half dx is equivalent to the integral of u raised to the power of half replaced by du all over what? All over 5. So we'll solve further to get our expression. So this gives us 1 over 5 integral of u raised to the power of half du. We're just taking bit by bit so that you can follow on and grasp it. So we have 1 over 5, which is u raised to the power of what? We're integrating now. Half plus 1 divided by 3 over 2, because 1 over 2 plus 1 is actually 3 over 2 plus our c. Then we'll recall that we have what? That our u is what? Not recalling now. So say u is equal to 3 over 2 divided by what? 15 all over 2. Mind you, we'll multiply this with this, the numerator, with this numerator. So that gives us plus c equal to what? U raised to the power of 3 over 2, 15, 3 over 2 over 1 divided by what? 15 all over 2 plus c. When it comes to this stage, you got to be careful so that you don't mix up things. So that is now u over u raised to the power of 3 over 2 all over 1 divided by 15 all over 2. And this gives us what? This gives us plus c. Then our next slide, we'll look at what we have done to finish up the work. Alright, we have u raised to the power of 3 over 2 divided by what? 1 with a bigger division of 15 over all over 2 plus c. Of course, when we fix it back like this, we change our division sign to multiplication, which causes this to invert. So we have 2 all over 15, close your bracket, plus what? Plus c. And that leads us to the next line, which will now have 2u raised to the power of what? 3 over 2 all over what? 15 plus c. But recall that u is equal to what? U has a value, an expression before, that u is equivalent to 5x minus 3. Put it in the equation, in this equation. Therefore, we have what? 2 in bracket 5x all over 5x minus 3, and that will be our next line of action. Thus, we have that what? That 2u now is now, our u is now what? 5x minus what? 3. We'll fix it here. Raised to the power of 3 all over 2 divided by what? 15 plus what? Plus c. And that is our result. That is where we stop for today. It has been interesting looking at integration. Integration is interesting. Also find it interesting so that you can learn and find fun in it. As you see the symbols of integration, like a music symbol, it looks like music in mathematics. Alright, so I hope you enjoyed this class. We hope to see you next time again. And if you have any question, reserve it. When we meet, we'll trash that out. And it's my pleasure to have you listen to this video. And I hope you'll be available for our next class. Thank you.